Okay, this lesson is on isosceles and equilateral triangles. So recall an isosceles triangle has at least two congruent sides, and the sides that are congruent are called the legs. The third side is referred to as the base. Also, this angle right here, angle 1, is called a vertex angle, because it's formed by the two sides that are congruent, and then the two angles opposite the congruent legs are called the base angles, and they are the same measure. And we have that basically written out in these two short theorems. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. If the two angles of a triangle are congruent, the side opposite those angles are congruent. And so that's a characteristic we have of the isosceles triangle. Equilateral triangles are also equiangular. So if we have three congruent sides, we have three congruent angles. And because by the triangle sum theorem, we know that the interior angles of a triangle add up to 180, you take 180 divided by 3, and you know this next corollary that each angle is 60 degrees. So then if we're given a triangle in the coordinate plane, then we need to use the distance formula to figure out the length of the sides to see if it's isosceles or if it's equilateral. So remember that if you've got those points graphed, you can use the fact that the distance formula simplifies to run squared plus rise squared. And we can kind of see that happening here going from K to P, because the run is 1, 2, 3, 4, 5, which is what we got when we applied the actual distance formula. And the rise is -1, which is what we got when we applied the actual formula. And so that's 25 plus 1 under that. Remember, when you square a negative, you get a positive. And so we end up with the square root of 26. And so then we can go do the next one from P to L. So we have 1, 2, 3, 4 going down. And 1, 2, 3, 4 going left. But again, it really doesn't matter if you square a negative or you square a positive, because you're going to end up with two positives, 16 plus 16, which gives us the square root of 32. So right there we know it's not equilateral. So now we just need to check the final side to see if maybe it's isosceles. So K to L, 1, 2, 3, 4, 5 is the rise. And the run is -1. We're adding those. And so we get 1 plus 25, which gives us square root of 26. So triangle KPL is an isosceles triangle. Okay, because we have this side is congruent to that side. Woohoo! All right, let's keep it going. So here we have find the missing measures. Find the measure of angle R. Well, right off the bat, as we look at this, we see that these two sides are 5 centimeters, which means that angle P and angle R are congruent. And so to find them, we would say 180 minus 60 and then divide that result by 2. But we know that 180 minus 60 is 120, and we divide that by 2, we end up with 60, which means we have an equiangular triangle. And if we have an equiangular triangle, then we know automatically it's also equilateral, so we know that PR has to be 5 centimeters also. Okay, find the measure of each angle. Find X and Y. So here we have an isosceles triangle, and we know this is X and this is X. And we know they all add up to 180, so I'm going to take 180 minus 50, and I get 130. And then I need to split it between those two angles. So I end up finding out that x is 65. And so if x is 65, I can find out the measure of this because this angle on the other side with x, that forms a linear pair right there. And so we remember, hopefully, if I take 180 minus 65, this angle is 115. Plus 65 gives me the 180. So if this is 115 and these two sides here are congruent, that's why I know that 2y plus 115 is equal to 180. Now I didn't do the algebra over here because I wanted to show that you don't have to write it out algebraically, but if your brain works better that way, then you definitely can. We could also use the exterior angle thing here because you're going to end up finding out that 2y is 65. When you go to do that, y plus y is equal to that exterior angle at 65 degrees. And so you could really do it either way. Y would become, let's see, that would be 37.5 would be y. And then we already have x right there. Okay, now let's look at this next example. These are isosceles triangle, which means that angle J and angle G are congruent. So those two expressions have to be equal because their measures would be equal. So 2x equals 44 and x is 22. I don't know about you, but substituting that into 3 times 22, to me that's easier. 22 plus 44 is just as easy. We get 66 degrees for both of those. Go us. Okay, more practice. We have equilateral triangles. And so because it's equilateral, we know it's also equiangular, which means that this L is 60 degrees. So 2x plus 32 would equal 60 degrees. So we would have to subtract 32 from both sides. We get a 0 there, and here we get 28. Divide both sides by 2, we get x is 14. And then over here, it's equilateral, equiangular. We know these sides are all equal, so those two expressions would have to be equal. So we set them equal to each other and solve. Subtract 4y from both sides, add 6 to both sides, and there's what we get. So just in case you missed that, subtract 4y, we get 0 there, add 6, we get 0 there, and we end up with y is 18. And that's what I thought. I thought that was the end of that lesson. So now you have a homework assignment in your homework packet that you can complete. Please get to work on that, and I will see you soon.